my general thought on this. I had an original panel. I was going to use a breaker disconnect on it. Ended up having to rip that out. Didn't have enough spaces and everything else. So I had the original panel mounted right about here. You can see I got to do a little bit of repair there. But that meant I had to open the meter case, fish some new wire in here, and I decided to put in a disconnect. You can see here I still have some stuff I need to fix up there, but this is the disconnect. It's a service rated disconnect, which means it can go before the main breaker, and then next to it is a main panel. I decided to upgrade the panel at the time, and that is now actually I've split into a sub panel. But in that cable there, you can actually see it up there, maybe, kind of. There is 4-aught SCR, and I will open this up. Does anybody know what arc flash is? And anyways, you can see this is coming from the generator here. I did have to do a little bit of stuff here to tie all the neutrals together in the grounds, because this is for the point of bonding the main panel where neutral and ground is bonded. It is not bonded on the actual main panel. Right now it's on utility, which comes in on the bottom there. You can see the neutral is clearly marked. I marked the phase. It doesn't really matter for single phase though, but I try to keep everything the same. And that's that. And then, of course, when you want to transfer, you get the generator started up, or not, or I mean, you can do it afterwards. But I get them started up first, then I just throw this. If I want to isolate the house, I just move it to the middle position. I probably will do a little bit of labeling here, but right now the middle position is off. So this is the main panel here. It is not bonded. I'm waiting on a transient voltage surge suppressor to go in there, but otherwise it's all done. There's my layout. Like I said, when I did this, I had to wire the entire house. This is a sub panel. This is the garage sub panel that's not even needed to be 150, but it is. This is for the sub panel. That's 4-aught going to the sub panel as well. And then there's my 60 amp for the shed. The rest of these are just circuits in the house, along with a little bit of 220 for I think an AC unit and the range, which is the kitchen and whatnot is on here. And again, rewired all this, went from one circuit in the kitchen to a bunch. And I'll go over and show the other side of the panel now, but this is the transfer switch disconnect. It's manual. It could be upgraded later on, but I wanted manual. It was simple. Okay, so this is the panel here where the generators are. Here's my two inlets. These are a 50 amp twist lock A and B. They will light up when there's power on them, but right now nothing's connected to the panel. This panel is completely dead. And it is fed with 4-aught SCR. I have my AC unit back here because this area of the house is furthest away from the master bedroom. Makes a little bit of noise. I have a smart start on this. This runs about 9 amps, 8.2 amps, something like that when it's running. Now it used to take about 35 to start. Now it takes 20. I'm trimming some of the trees here. So I have generator number 1 there and generator number 2. When I hook these up, I have some cables made here that go from the twist lock to that, and then plug in here. And in general, the procedure, and I need to fit this in here, I just haven't had a chance to do it yet. I have them both on 50 amp breakers, even though they're only capable of 30 amps. Here's the power going out to the house, ground. I will mention the generators have no ground tied to neutral on them. I had to open them up, remove that, because you cannot have that bonded at the generator when you're connecting to a house like this. And this is 4-wire cable. This is number 6, so certainly capable of handling 50 amps. My wires that I feed it with is only number 10. Again, not an issue. If I get a really big gen set at some point, I can still use this here. This is the again, this is dead, so it's safe to touch. This is terminal, so same thing, QO breakers, and it's got a main breaker here, not that it's needed. General procedure is, and I'll walk you through this. I start one, transfer it, get it going, kick this on. Now this is live, but this is off. Connect to the other one with the power, or sometimes I'll connect it first. Now this will be live, this one will be live, and then I transfer and start the other generator. That way they come up synchronized. And once all that's going, I throw the main breaker and then go over and throw the switch. I'll show you how all that works here in a minute. Okay, this guy, that's the ground pin on this. Okay, twist lock, it's in there. It does have these optional weatherproof weather boots that go on here. You can twist on if you want. That's one. Number two here. And twist. And it's in there. So we're good there. I'll hook these up to the gen sets. Okay, twist lock in here. It is windy here today. I always make certain I do this on the number 2 generator, and there we go. So the breaker's off here, everything's shut off here. This will be the second one I start up. Okay, the AC unit kicked on behind me, but here we are. This is generator number 1, the purple. This is the first one I'll start up. That's how I track the wires. So first things first, make sure the throttle is off, throw this to on, turn this to run, and we'll crank. Okay, good. Going to run. We're stable now. I'm going to energize this breaker. Now I have power on this cable. You'll see I have light here, meaning this has power on it. However, this breaker is shut. Okay, now this is live. There's 220 on the panel. However, this breaker, going to the other generator, is closed, and I need to energize that because I want to have power on that other generator before I start it. Okay? I got power on there. You can see the light come on there. I think if I go like this, it's easier to see. Okay, let's go over here to this generator.
Okay, so right here is where we had an issue with the first generator. These kind of got swapped around. I'm sorry about that. The inverter module actually died in one of the generators while I was filming this. So I had to order one and replace it. It was a pretty easy swap. It's about $300. So the order of operations here is swapped, unfortunately, but it's still the same general idea, and I'll give you some ideas for doing this yourself.
17 amps total. This one is shut off. It's disconnected from the bus bar. So you'll see this cable here. It's totally disconnected. So the first thing I'm going to do is plug this cable in. Right now, there's no power on this. So let's see, that goes there. Okay, and we're locked in now. Make certain the breaker is up. So this way, when it gets power on it, we'll put power on the control board. Turn the throttle off here, so it's on that. We want to be in choke mode when we actually do start it, but we're shut down right now. Let's see where we're at on amperage. 19 amps, so we went down a little bit. Okay, this guy's in throttle mode. I'm going to shut that off. You'll hear it spin up. Okay. We're ready here. What I'm going to do is I'm going to throw the breaker here. You'll see that'll turn on the light here. Okay. We got power going to the generator now, but it's not on. Okay, we're here. Power's on, meaning it's going to the controller. We're in choke. ESC mode is off. Turn it on. Start it. And we're on in parallel mode right now. Let this run for a minute or two and we can throw the ESC mode on. It's actually running before. Still drawing about 18 amps, AC's on. You can see we're doing about 9 amps here from the generator we just started. And 10 amps over here. So it's pretty well balanced. Okay, so now I'm going to turn on the primary generator. And we'll throttle down. And we're throttled down to gas saving mode. It's still supplying about 8 amps. 10 amps over here, which is pretty well balanced, all things considered. Total about 18.5 amps to 220. Let's see what we got on neutral. Yeah, it's pretty well balanced. Most of my heavy loads are 220. And that is how you parallel two generators through a QO panel.